Here's a SLAI question, and so we just go and read the question and see what's happening, right? We have a polygraph test is used to determine whether people are telling the truth or not. Okay, so it sounds like there's two outcomes here: truth or not. Maybe it's a binomial. It is not completely accurate. When a person tells the truth, they have a 20% chance of failing the test. Okay, each test outcome is independent of any previous test outcome. 10 people take a polygraph test and all 10 tell the truth. Okay, so this is quite interesting, isn't it? All right. So if you actually do tell the truth and you do this test, you might have a 20% chance of failing. So I'm just going to put P equals 0.2. I'm going to put N equals 10, and already I can see that this is shaping up to be a binomial question. All right. 10 people take the test. All 10 tell the truth. But each time a person takes the test, there's a 20% chance that they actually might fail a test, even though they're telling the truth. So that's the confusing bit, I think, right? A, calculate the expected number of people who will pass this polygraph test. Well, look, I'm just going to put a little variable, x equal the number of people who pass the test, right? The number of people who pass the test, okay? And so basically we're going to have x can be modelled by a binomial. N is the number of trials. Now look, x is the number of people who pass the test. So what's the probability of passing? Because we've got a 20% chance of failing, right? So that means an 80% chance of passing. So this is key, right? Now when you go to the formula book, you've got calculate the expected number of people who will pass this test. Well, common sense says if it's an 80% chance of passing and there's 10 people, then 0.8 times 10 is indeed 8. The formula book gives you this: E of x equals n times p for a binomial. So that's the 10 and the 0.8. So if you're unsure, then that's where to reach for. There's A. And here's B. Calculate the probability that exactly 4 people will fail. Well, that's a little bit naughty, right? Because our x here is the number of people who pass. But look, I can write this, right? Probability that x equals 6. So if I want 4 people failing, then I want 6 people passing, right? So that's a sneaky way of getting around it. So P of x equals 6, so it's going to be a binomial PDF. I won't go to the calculator just yet. Let me set up part C now. Determine the probability that fewer than 7 will pass the test. So we're back to passing the test x. So that's probability of x is fewer than 7, right? Fewer than 7. So fewer than 7 means 6 or below. So that's probability of x less than or equal to 6, right? Okay, so that looks like I can switch now to my calculator. Bring this little guy out and put these side by side so we can see what we're doing. And now let's make that a little bit bigger. Let's go view, zoom, go back to 150. Okay, that should do it, I think. Maybe a little bit bigger. And then I think we are in. Thank you for your patience. Great. Okay, so menu, probability distribution. Right, so probability distribution. A binomial PDF, number of trials 10, success is 0.8, and the x value here is 4 we want, right? Oh, sorry, my bad, 6. Okay, it says 6 here, right? Okay, 0.088, let me just check the last digit, 0.0881, okay, 0.0881. And now let's go back again. Menu, probability distribution, binomial CDF to accumulate, number of trials 10. Remember, the probability of success is 0.8. The lower bound is the lowest number of successes. It's already defaulted to 0, right? That's great. And the upper bound is 6. We include the 6. Okay, 0.121. So 0.121. All right, so the secret there is kind of thinking, well, what's all the information given in this question? It says there's kind of 10 people. So that's kind of a big clue that it's probably binomial. But then it's a case of is P 0.2 or 0.8? And that really all depends on how you set up your variable. So maybe you just read down the question and you think, well, part A talks about people passing, part B talks about people failing, part C talks about people passing. So look, 2 out of 3 is about people passing. So in fact, it's probably better, right, to do exactly what we did and have P equals 0.8, the probability of passing. Okay. You can flip it the other way and kind of rethink it about the number of people failing, but I think with part A and part C being about people passing, it makes more sense to have P equals 0.8, let X equal the number of people who pass the test.